All right, good evening. So my name is Fabrice Drouin. I work for A5, a small startup company funded 3 years ago, and we work on Bitcoin and more specifically on the Lightning Network, which is a scaling solution for Bitcoin. So we have 3 projects. It's a Lightning node. I will explain what it's about later. A mobile application and tools and libraries that you can use to make using Lightning and Bitcoin a bit easier. So I'll start with explaining what Bitcoin is. So how many of you own Bitcoins? Okay. Bitcoin, basically, that's Bitcoin. If you want to have an image of what Bitcoin is about, Bitcoin is digital cash. So whatever you can do with cash, you can do with Bitcoin. That's the model you have. And it's the holy grail of digital cash because people have been trying to build digital cash without trusted third parties, without central banks for a long time, for nearly 30 years. And somehow someone or a group of people named Satoshi Nakamoto managed to combine multiple tools and techniques and create, for the first time, trustless digital cash. Cash that you can transfer without having to rely on trusted third parties. It was the first time. So Bitcoin is decentralized. It doesn't have central authorities. It's a peer-to-peer network. It is trustless. That's very important in Bitcoin. You don't need to trust anyone. You can verify everything yourself. And it's based on cryptographic primitives, which is why it is called a cryptocurrency. So in a way, you have an old centralized model on the left with a center. And when you get closer to the center, you have more and more verification and trust and things you need to comply with. Bitcoin is very different. There is no center. It's a network of nodes connected together, but there is no central point of failure. There is no central authority. It is a very different model that is based on a global consensus. All Bitcoin nodes agree on what the blockchain is, and it's a really hard problem to get global consensus, and it creates limitations, especially when it comes to the scalability of Bitcoin, and that's what we're working on. So how to become a Bitcoin expert in 3 easy steps: the blockchain, the UTXO, and the script. Does anyone know what UTXO means? Except for Chris, of course. Okay. The blockchain is the first step. It's the step that most people are familiar with. Bitcoin transactions are grouped into blocks. Blocks are linked together. So a block contains the ID of the previous block. And there's a proof of work in Bitcoin that is very simple. The hash of a block needs to be smaller than the target value. So this is an actual hash. And do you know what a hash function is? Okay, so the result of a hash function is supposed to be basically random numbers. And this doesn't look random at all. It starts with a lot of zeros. That's the proof of work. So to create a hash that starts with that many zeros, you need a lot, really a lot of computing power. And that's the key to the security of Bitcoin. If you want to create a block, you need to do a lot of computations. If you want to change the blockchain, if you want to say, okay, I want to replace this block with another one that gives me more money, you need to rewrite the blockchain. You need to rewrite the blockchain by finding blocks that will hash to the given target, and that's extremely difficult. Today, we consider that it is nearly impossible to rewrite more than 6 blocks. So if you're there, basically, you're safe. What is there is never going to be changed again. This is a fork in the Bitcoin blockchain. So this is a valid chain. This also is a valid chain. So This happens once in a while. For example, miners could start from the same block and two miners could find a new block at the same time. So how do you decide which one is the good one? It's fairly easy. You choose the chain with the most proof of work. So it's deterministic. So in this case, this one is the chain with the most proof of work, and that's the valid chain. And there's an incentive for miners to follow the most valid chain, because mining is a race that starts from crash every time a new block is produced. So suppose we're there. A miner finds this block, another one finds this block. To keep on following the chain that is not the longest one is losing money. It's a bet that you will be able to catch up. If you don't, everything there is lost. So the incentive for miners is to always follow the longest chain, and this is why Bitcoin works. So what you have is a peer-to-peer network of nodes, and they all send and receive transactions and blocks. And they all have to agree on what the blockchain is. It's a global consensus problem, and it's really hard. That's why there's one implementation of Bitcoin now. The Bitcoin Core is like 99.99% of all nodes, because if you're running software that produces different results from what Bitcoin Core does, you will fork off the network, and it's really bad. So it's a bit strange when you discover Bitcoin, but there are no specs. There is code, and you have to do exactly what the code does. And if it has bugs, you need to replicate those bugs. Another thing that is really important to understand Bitcoin is the transaction model. How do you define the coins in Bitcoins? What are the coins in Bitcoins? The coins are the outputs of transactions that have not been spent yet. It's fairly easy. So Bitcoin transactions have inputs and outputs. The inputs spend a previous output, and they create new outputs. So we call this the UTXO model. UTXO stands for unspent transaction output. So for each block in the blockchain, if I suppose so there's a given UTXO set. A new block comes in with transactions that will spend some of the outputs and create new outputs. So it will change the set of UTXOs that are spendable. That's how the Bitcoin blockchain works. So what is really important, the state that you need to keep is the set of spendable transaction outputs. And it's very easy to check if a transaction is valid. You can only spend money that is in the UTXO set. So this model is a bit different from the commonly used balance model, where you have accounts with fixed IDs and you can send or spend money from an account. This is different. UTXO exists only once. They are created, they are spent, and they're gone forever. You will never have twice the same UTXO. So what the Bitcoin wallet does is keep tracks of the unspent UTXO that you can spend. If you have a private key, you can spend the UTXO that send money to that private key, and that is your money. That's how Bitcoin works. You don't have a concept of accounts and balances. You have a concept of transaction outputs that you can spend. So this looks a bit strange at first, but it's not that hard to understand, and it's one of the differences between Bitcoin and other cryptocurrencies that have chosen an account model. It's really easy to implement from a system point of view. And that's one of the characteristics of Bitcoin compared to other currencies. A lot of things in Bitcoin were made to make implementing the system easy, which means that sometimes implementing clients is a bit harder than it is for other currencies. But from a system point of view, it is fairly easy.
I haven't understood the purpose of UTXO. You don't mind?
The UTXO is because the biggest problem for Bitcoin is to solve the double spend problem. That is the key to creating digital cash. How do you check that I am not sending money to you and the same money to Chris? That's the huge problem that was not solved before Bitcoin unless you resorted to using a central controlling authority that could say, okay, that would order transactions and say, okay, you can't spend this one because I already saw it. How do you deal with double spending on a peer-to-peer network? And so the UTXO is part of the blockchain solution to this problem. You have a set of coins you can spend, and a transaction to be valid has to spend something from the set of spendable UTXO. If it's not there, either it doesn't exist yet or it has been spent already, but it's not valid. And the third thing that was mentioned by Chris before is the script. Bitcoin has a really basic scripting language. It's a stack manipulation language. So you have a stack, you can push values to the stack, retrieve values from the stack, do simple computations, and that's how Bitcoin works. For example, if on the stack the first two elements are 1 and 2 and your operator is add, it will pop the first two values from the stack, add them, and push back the sum of the two values. That is 3 in our case. So it is extremely simple, and it's very easy to analyze from a static point of view. That's one of the strengths of the Bitcoin script. Even reading scripts gives you a pretty good idea of what it is doing, and there are no tricks, no subtle bugs that you could have if you had more elaborate scripting languages with the loops and things like this. Bitcoin script is basic, but it is actually a good thing, not a bad thing. And the way it works is transactions have inputs and outputs. Inputs have what we call a signature script, and outputs have what we call public key script. And to check that a transaction is valid, you start with an empty stack, you execute the signature script of your input, so you get a stack with values on it. You execute the public key script of the output that you are trying to spend, and the final stack should be one element, that is 1. If it's anything else, then the transaction is not valid. So it's very simple. You run 2 scripts, you should have a stack with one value, that's 1. It's an interesting property because one of the things that people are looking at right now are zero-knowledge proofs. Zero-knowledge proofs is how do you prove that you know something without disclosing what it is exactly that you know? And there are people working on systems where you could prove that the execution of scripts gives you a single value that is true, but you don't say exactly what the scripts are. So the values in the script, which could be, which you may not want to disclose for privacy reasons, will not be disclosed to everyone. But you can prove anywhere that the execution of the script is valid, it gives you a single value. So it's one of the things that people are working on. So these are examples that we saw earlier, so I'm going to go quickly over them. That's public key script, the most widely used script in Bitcoin. You have more advanced transaction scripts. And in Lightning, we have much more complex scripts. I'm not going to show them, but more involved script, but basically it's all the same principle. You have simple operators like hash functions, signature verification functions. You push values and you do things with them. So it's a very, very simple language. It's a no-brainer. And it's one of the strengths of Bitcoin, not a weakness. So there's a huge limitation with the public blockchains. It's not only Bitcoin, it's all the other public blockchains. It's scalability. The design is everyone sees everything. Everyone sees all transactions on a Bitcoin network. What it means is, for Bitcoin, you get 7 transactions per second for the whole world. That's not that much. It also means that a payment is considered final once it's been confirmed 6 times. Once the transaction that includes the payments has been followed by 6 blocks, 5 blocks, sorry. Having payments that take 1 hour to be processed is a problem for many use cases. There's another problem with Bitcoin. You can't do micropayments anymore. There are transaction fees, a few cents now, which means it is not practical to send a 5 cents Bitcoin transaction. So for some use cases, Bitcoin is not usable right now. But the biggest problem is throughput. 7 transactions per second is really not much. So if we want Bitcoin to succeed as digital cash, we need to solve this. So you could have bigger blocks. You could have Bitcoins right now is limited to 1 megabyte per block. So they could be bigger. You could have a shorter interval between blocks. Bitcoin is 1 block every 10 minutes. It could be 5 minutes, it could be 1 minute. It has side effects. But this is not how you'll get thousands of transactions per second. So we need to find something else. And that something else is a Lightning Network. Lightning is a peer-to-peer network of payment channels. It is based on the Bitcoin blockchain. It speaks the Bitcoin protocol, but it has a different model. And it enables cheap, instant payments. It enables micropayments, and it doesn't have a throughput limitation. Basically, the throughput on Lightning is unlimited. And it is still trustless. Maybe a bit less than Bitcoin, because I'll explain later, but it is still a trustless system. And it's a layer 2 application because it is based on the Bitcoin blockchain, but it's above it. And it has different properties, different trade-offs, but it's true to the Bitcoin spirit. It is still trustless. So it was proposed.
So it's a competitor to Bitcoin?
No, it's a layer above Bitcoin. But Lightning does not exist, cannot exist without Bitcoin. It relies completely on Bitcoin for everything. So it was proposed 4 years ago. Someone proposed payment channels for Bitcoin, but there are lots of limitations. And the biggest limitation is you had to open a channel with everyone you wanted to send money to. So if you wanted to buy from Starbucks and Microsoft and blah, 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 you had to open one channel with every one of them. It was not practical. And 2 years ago, Joseph Poon and Taj Dryja proposed the Lightning Network, which is an extension of payment channels with conditional payments. That is, you pay someone if and only if they pay someone else. This property gives you a network of payment channels where you can pay anyone you can find a route to. And that's one of the keys to Lightning. It was improved and it evolved into a community that has been working on specifications for a year now. The specifications are almost ready. So there are 3 major companies working on Lightning. There's Blockstream, Lightning Labs, which is based in the financial district, just a few minutes away, and there's us. So the specifications are almost ready. There are 3 implementations almost ready and interoperable, so you can choose any one of them and they all speak the same protocol. And hopefully there will be the first test with real money within the next few weeks. So it is getting ready, and it will be deployed, I think, by the end of this year and beginning of next year. So we'll start small with small payments, but it will be deployed in real life very soon. So the bolts are the basis of Lightning technologies. So you can check out the specs and see how it works. So it covers everything. And the idea of Lightning is that you create Bitcoin transactions that are valid, but you don't publish them. And when you want to pay someone, you change how these transactions split the money they spend, but you don't publish them. So for example, when you create, Alice and Bob create a payment channel, and in this case, Alice is funding the channel. So Alice will publish a Bitcoin transaction for 10 Bitcoins that can be spent only if Alice and Bob sign the spending transaction. It's like a joint account. You can spend, but both parties have to sign. So this one gets published to the Bitcoin blockchain. And Alice and Bob, they will have what we call a commitment transaction. It spends from the funding transaction, but it is not published. When you start, Alice is funding, so Alice has a commitment transaction that gives her 10 Bitcoin and nothing to Bob. And Bob has the same. He has a commit transaction that gives Alice 10 Bitcoin and nothing for him because it doesn't have money. And basically when Alice pays Bob, they just change how the money in that funding transaction is split. So if Alice wants to send 3 Bitcoins to Bob, they will change the commit takes, and now it gives 3 Bitcoins to Alice and 7 to Bob. And they will update how these commit takes spends the funding takes, but they won't publish it. So this you can do 1,000,000 times. You can do it back and forth, you can change the balances. It never leaves the channel, it never touches the blockchain, so there is no global consensus, and there is no scalability issue anymore. And when Alice and Bob are happy, or every week or every month, they will close the channel, publish the state of their commitment transaction, and it will go back to the Bitcoin blockchain. So from the blockchain's point of view, you have 2 transactions, the first one and the last one, and everything that happens in between is just between Alice and Bob. It doesn't touch the blockchain. So this is a payment channel between Alice and Bob. There's a very simple payment model in Lightning. It's called hash time locked contract. So I will give you Bitcoins if you give me the pre-image of H. You all know what a pre-image is? No. Okay, so you have a value, you hash it, you have a result. That first value is the pre-image for your result. And hash functions are impossible to invert. You need to try all possible inputs to get an output. So if I give you a value y, there is no way you can find the x that can be hashed to y without trying every possible value. So it's not possible to invert. So the payment model in Bitcoin is, I will pay you if you give me the pre-image for a given value. And so that's why we call it hash contract. You pay against the pre-image for a given hash. And it's time locked because suppose Bob stops responding. It goes away, dies, whatever. You need to get your money back. So after a delay, if you haven't gotten your pre-image, you get your money back. So the Lightning payment model, I will give you money against the pre-image, but after a given time, if you have not given me the pre-image, I can get my money back. So a payment in Lightning is an amount. A payment hash and a delay. And the trick that makes Lightning really awesome is conditional payments, multi-hop payments. You can pay through someone. That's what makes it really interesting, because you don't need to open payment channels to everyone you want to pay. As far as, I mean, if you can find a route to someone, you can pay them. So suppose Alice wants to buy something from Carol. It's on a website. Alice sees a really nice image of a cat and she wants to buy it. 2 Bitcoins. It's a very expensive image of a cat. So on the website, Carol will display a payment request. It could be a QR code. It could be anything, and it says, "Send me a payment for 2 Bitcoins." And Alice will send that payment, but through Bob. Basically, Alice will say, "Okay, Bob, I will give you 2 Bitcoins if and only if you give Carol 2 Bitcoins." That's how it works. Basically, Alice will send a payment to Bob using this H value she got from Carol, and Bob will forward the payment to Carol with the same H value and the same amount. And now, what happens is, when Carol gives the pre-image to Bob, Bob will give it to Alice, and transfer is done on both sides. So what happens is now 2 Bitcoins have moved on this channel from Alice to Bob, and 2 Bitcoins have moved on this channel from Bob to Carol. So from Alice's point of view, she's paid 2 Bitcoins. From Bob's point of view, he's received 2 Bitcoins from Alice and is given 2 Bitcoins to Carol. And from Carol's point of view, she received 2 Bitcoins from Carol. So that's how payments work on Lightning. You transfer money from one inbound payment channel to an outbound payment channel. So from Bob's point of view, it doesn't change anything. But Carol got paid and Alice paid. And it is still trustless because of the constructions that are used in Lightning networks. At all times, Alice, Bob, and Carol have valid commitment transactions that can be published to the blockchain. And they don't need to trust each other. It's either you, how could I say that? The fact that your commitment transactions is always valid means that you don't trust your counterparty. And so it's a very specific payment system because there is no custody. Bob, you transmit money, but you don't control the money that is transmitted. I don't know if you see what I mean, but it's very different from the traditional systems where basically money transmitters, they have the money and you ask them to transfer it. But it is their responsibility and they can do whatever they want with it. Here it's different. Bob does not control the amount, or he cannot change the pre-images, or either he relays the payment or he doesn't, but he cannot steal the payment. So it's a trustless model that is different from traditional payment processing systems.
Why wouldn't Alice just send the money to Carol?
Because she could if she had a payment channel with Carol, but the thing is, it's not practical. If there are thousands of merchants, you don't want to open channels with every one of them. If on a network of payment channels, you only need to have a few open channels, maybe 3 or 4, and it's enough to pay anyone on the network.
So Bob will be like an intermediary, like a
Yes,
bank today.
yes. Except that you don't need to trust Bob.
happens if Bob doesn't relay the payment?
He doesn't get paid. If Bob, on this side, Bob is paying. On this side, he's receiving money. So it doesn't make sense for Bob not to transfer the pre-image, because if he doesn't, he doesn't get, he pays on this side and he doesn't get paid on this side. So there's no incentive for Bob to not relay the payments. And from Carol's point of view, what Carol wants is to get paid. She doesn't care whether it comes from Bob or Alice or whatever. So that you see what I mean?
I mean, like, just thinking more ahead, like if Bob was a bank, let's say, and Carol was a criminal, and then Bob didn't want to make any deals with Carol, right, because she's a criminal.
Yeah.
Is there a way to kind of say, like, hey, you know, like, if I'm, I don't know, like a bank, and you want to have a channel with me, you have to kind of prove who you are. You have to say, oh, you have to show, you know, who your customer, all that, and then we can do some business here.
Maybe, but there's one thing that is specific to Lightning that doesn't exist with mining, for example, is there is no barrier to entry. You could mine at home, you will never find a block, ever. You'll be dead before you find the first block. Lightning is different. It's permissionless network, so anyone can run a Lightning node. So if you don't want to go through Bob because Bob is doing things that you don't like, there's nothing that prevents you from going through someone else, because anyone can run a Lightning node effectively. I don't know if it answers your question, but
Yeah,
it is a permissionless payment system with no barrier to entry.
So there's no infrastructure limitations that is letting me not become.
No, no. No, mining, if you don't have millions and millions, it's not going to work.
Right.
You could run a Lightning node on a small computer at home, and you could create a small network of payment channels in your city or university or whatever, and it will be used. So it's a very different model from mining.
Could there be multiple Bobs and just
Yes.
how do you identify the first one that you relate is the one that succeeds, the other Bobs get declined?
Basically, this is maybe. Okay, I'll talk about the routing because I think it answers your question. Lightning uses onion routing, a bit like Tor. What it means is the sender chooses the path on the network to the destination. So what it does is you create a message for the destination that you encrypt, and you add a layer for this node that is encrypted, and so on and so on and so on and so on. And when you receive a message, you decrypt it, you peel off the layer that is for you, it tells you where to send it next, and that's what it does. But when you're in the middle of a payment, you don't know where it comes from or where it's going. All you know is this one knows it came from here, and it goes there. It doesn't know the sender or the destination. I don't know if it answers your question about Bob not willing to send money to Carol, but basically, when you're there, you don't know who's paying who. So there's a good.
So just to go back to the Bob thing. So what you're saying is that I wouldn't know. Let's say that I'm Bob and I don't want to make business with Carol. Well, then Bob makes a channel with Alice. Is there a way for Bob to see that Alice has channel with Carol, and then see like, hey, you shouldn't be doing business there. I'm gonna close your channel.
You could, because to bootstrap the network, we'll use a gossip system where everybody has a complete map of all channels. So you could decide not to relay payments to. No, you could not. Sorry. No. Here you could decide not to use a given channel because you don't like it.
Right.
But there's not much you can do. You don't know where it's going. So if you don't like the the destination there. There's no way you can censor the payment unless you control more than one node on the route, which is always possible. It's also one of the attacks on the Tor network. If you control entry node, exit nodes, and nodes in the middle, yes, there are things you can do, and it will be the same with Lightning.
So
But-
intermediate nodes only see the next node.
Yes. You see this one, and that's it. You don't know the standard destination. The payment hash is the same, which is a bit of a problem. It's something that will be changed with for the next version. So you could use the payment hash to correlate payments, but you don't know the routes when you're relaying payments. So Lightning is not a sidechain. It is not independent from Bitcoin. It is a layer above Bitcoin that uses the same transactions, the same protocol, the same scripts, with a different model that makes it basically unlimited from a throughput point of view, with also new limitations. Bitcoin, one of the good things about Bitcoin is you can receive money without doing anything. If I was to display a QR code with my Bitcoin address, you can send me money, and I don't have to do anything. I don't even have to run a computer with a Bitcoin node. Lightning, you need to be online to send money, and you also need to be online to receive money. That's one of the big differences between Lightning and Bitcoin. You need to monitor the blockchain. So I didn't go into the details, but to prevent sorry. Okay, suppose we're there. Alice has 3 Bitcoins and Bob has 7 Bitcoins. And Alice thinks, okay, I like this one better. It gave me 10 Bitcoin. I'm going to publish this one. You need to prevent this. So we have a revocation mechanism based on penalty transactions that basically if you publish an old commitment transaction, you lose all the money in it. But for this to work, you need to monitor the blockchain. You need to see that somebody is spending the funding transaction, and you need to steal the outputs. So it's a constraint. It means you need to monitor the blockchain, or you need to have someone do it for you. So if you're running a node on a system that is not online very often, like a mobile phone, you have a problem. So the easy way out is to say, okay, I don't receive money. All I do is send money. So you don't care about someone publishing an old transaction because it will give you money. If you want to receive money on a system that is not online for a long time, like a mobile phone, you need to outsource blockchain monitoring. There are really clever ideas on this. It can be done in a trustless manner. But it's one of the constraints of Lightning that doesn't exist with Bitcoin. You need to monitor the blockchain if you want to receive money. So now I'll talk about what we do with Scala and why we think it's a good fit for Lightning. So we have several projects. We have a Bitcoin library that is a bit similar to what Chris is doing. It includes everything you need to parse the blockchain and create some transactions, but it's mostly focused on creating transactions. We use it on our Lightning nodes, so what we do with it is create and spend transactions. So it's really what we focus on, creating transactions. We have a Lightning node. So it's basically like it's similar to the Bitcoin Core node, but it's used to create and manage Lightning channels. So it's there's a headless mode and a JavaFX GUI. And we have a mobile application that is not open source yet, but will be very, very soon. And it includes a wallet, and you can use it to send and receive payments. So you can download it on Google Play, but it's only usable right now on testnet, so it's not real money. And this is an explorer that will show you the network of payment channels. This will be released very soon too. Why did we choose Scala? So we are building Lightning nodes, so we are building servers. What we need is performance. We need to monitor what we're doing. We need logging facilities. We need networking libraries because we are connecting to other nodes. We need something we can deploy easily, and we need to handle concurrency. We don't care about startup time. The size of the runtime is not really a problem because we have long-running servers. And for this, the JVM is a really good choice. Also, we use state machines everywhere to model what we're doing. Basically, a Lightning channel is modeled as a state machine, and there are very good tools in Scala for modeling state machines. And we also need crypto primitives and Bitcoin primitives. And we'd like to have, it's a very nice to have, we like to have something we can run on phones and not just desktop or servers. So why did we choose Scala? Because of the runtime, because of the language, and because of the tools and libraries you get with Scala. The biggest selling point, in my opinion, for Scala, for this type of project, is the runtime. The JVM is an amazing runtime. It's underrated, but it's really, really good. It's battle tested. It's used on millions of servers everywhere for every type of applications. There are really good runtime tools for the JVM. You can monitor what's happening. You can debug. You can deploy. It's really good, and you have very good development tools. So the JVM runtime for this type of application is, we believe, a very good choice. The language, what is the most important feature for a programming language? We believe it's readability, as in the ability to convey what is the intent behind the code. And it's always subjective because it depends a lot on what you're doing. If you're doing algorithms or if you're doing crypto, you will have a different opinion on what makes code readable than if you're doing GUI or JavaScript or database access or workflow processing. But you don't want something that is too verbose because you get lost. You don't want something that is too clever, too terse because of the Perl syndrome. So I don't know if you remember Perl, but in the 90s it was supposed to be the next big thing. Everyone was writing Perl scripts for everything and rewriting them a few weeks later because they couldn't remember how they worked. And I'm not kidding. I met sysops who just went on rewriting the same script over and over again because it was impossible to read. If your language is too low level, it will be hard to quickly prototype new ideas. Again, it depends upon what you're doing, so it is not generic. And if it's too high level, it might be hard to switch from prototype to production. So again, it depends on what you're doing, but we believe that Scala is a fairly good compromise for this. You can express things in a few lines of code, and you can still be efficient, and you can turn prototypes into production without having to rewrite most of it. So from our experience, it's a fairly good choice. What I mean is, it's fairly easy, in my opinion, to write meaningful code in Scala. The basic language features like case classes, pattern matching, immutability, and the collection library makes it really easy to write things that convey the intent behind the code easily. Immutability, for example, it could be done in any language, but it helps you get away from the side effect problems that you have in other libraries. There are libraries, BitcoinJ is, I think, such an example. You have side effects everywhere. It's really hard to understand what's going on because you can't look at something and understand what it does without looking at something else at the same time. Immutability forces you to work differently, and it's a good thing. and the tools are very good. Basically, whatever you need, there's a Java library for it, and it's used by lots of people. It's tested and it works. And you don't ever have to rewrite low-level stuff. You have libraries for graphs, crypto, network, all types of formats. This is really nice because it helps you to prototype new ideas very quickly without having to write low-level things that you are missing. And it's a very good point for. It's not specific to Scala. It's true for Java also, but it really helps. There are very good development tools, very good debuggers. There are mature build tools. Okay, we use Maven. I don't know. We use. Is anyone using Maven for Scala? Okay, not many people. We do. We are very, very happy with it. Build systems are boring. I don't want to learn a new one, so I know this one, and it suits me. There are good testing frameworks. It's easy to integrate with Travis, and it's very easy to deploy on Amazon, for example. So the tooling that comes with Scala are, in our opinion, very good for what we're doing. Akka is, who is using Akka? Okay, so Akka is an actor library for Scala. So the actor is a concurrency model where everything goes through message passing. It's a very, very nice library because it's really easy to reason with. The actor model, that's almost one of its, it lures you into building prototypes with message passing, and it hides the complexity that you have to deal with later, like back pressure and persistence and complex workflow. But it's very, very easy to prototype and reason with the actor model. Some people say it's almost a good enough reason to switch to Scala. I don't know if it's true or not, but for some types of problem, Akka is really nice. But it's not a silver bullet, and there are problems that are really hard and that cannot be handled at the framework level. Back pressure is one of these examples. Back pressure is you produce on this side you produce too much data for this side to process. This is not something that a framework will handle for you. You need to decide what to do. Either you discard some of the requests there, you queue, you tell the guy who's producing data to produce less. You need to choose, but this is an application choice. It cannot be a framework choice, so it's hard to handle. When you're building systems that are connected to other systems, persistence and disconnection, reconnection are really hard to handle. And again, this is something that is application specific, so the framework will not decide for you what is the right choice. So this is something that is hard to implement, but it would be hard to implement with any tool that you would choose. So one of our gripes with Scala right now is Android, because Android is stuck as Java 7, which means we can't use Scala 2.12, we're stuck at 2.11, we can't use the latest version of Akka, and there are more and more libraries that are switching to Java 8 and that we cannot use. And this is a language problem. It's not a language problem, it's a tooling problem. So Kotlin will not save us because Kotlin will not solve the library problem. If the tools and libraries that you're using are not compatible with Android, Kotlin is not going to help. And this is something we're seeing more and more. I think it will eventually solve itself, because having a development system that is far behind, that becomes specific, would be a problem for everyone. So I think eventually it will catch up. But right now, it is a problem. We'd like to have the same code base on servers and phones, and it's a limitation. The community around Scala, Scala is not as popular as we expected it to be a few years ago. I've been using Scala for a long time, almost 10 years now. And in 2008 and 2009, there were lots of expectations. I don't think they've been met. I don't know what you think, but it is not the next big thing. So it's not like Golang is extremely hip now. Rust is very popular in a cryptocurrency community because of the low level features and security features. Scala not that much, and I think with only 2 guys working on Bitcoin and Scala right now. There are not many people. But it's not that bad because we found that Scala acts as a filter. We don't get many contributions. We don't get many people interested in what we do because of Scala. But they're always very good contributions, always very interesting. There's one guy in Ukraine that is doing an amazing job on our open source project. And I'm not sure we'd be better off with a more popular language and more people and maybe lower quality contributions. So it's a small community, but so far it's not been a problem. And it's not something we worry about anyway. I don't know if it's the same with you, but Scala developers are, I don't know, I would say they have maybe a more complete skill set than people you find in other communities. I'm not trying to be, but it's not that bad. And so that's it. Do you have any questions? Yes?
For the Lightning Network, is it possible to have a situation where one user isn't connected to another, or there isn't a path from one user to another?
Yes. In that case, you can't use Lightning. You need to fall back to the Bitcoin blockchain.
Can you describe some of the places where you use Akka and what's been your experience there?
Basically, the Lightning channel, it's one huge Akka state machine. The transport layer, it's also an Akka state machine. Akka works very well, especially when you begin a new project or a new prototype. It's very, very easy to prototype with Akka. And it's a problem because the back pressure issues, you don't get them until you're far along, and maybe it's a bit too late to switch to something else. But basically, everything we do in our Lightning nodes is an Akka actor. The channels, the peer above the channels, the encryption, we use it a lot.
Is there any issue, is there any issue you have like different implementations in different languages in Lightning as there is in, with Bitcoin?
No, because the problem with Bitcoin is it's a global consensus. There are thousands of nodes and they all have to agree on exactly the same thing. It's not the problem we have in Lightning. It's a peer-to-peer network, but payments are routed. Interactions between a channel has no impact on the other channels. It's more like a traditional client-server communication. So it is very possible to have specs, and it's very possible to have different implementations because they won't impact the whole network. So today we have a spec that is, I think, fairly readable, and we have 3 implementations in Golang, in C and Scala, and there might be others, but it's not a problem at all because we don't have a global consensus problem.
No question. So you guys announced that these 3 implementations
Yes.
are going to be interoperable.
Yes.
So in what sense will they be interoperable? What did you agree on?
Basically everything, the wire format, the Bitcoin transaction format, how you handle disconnection, reconnection. It's like you will be able to route payments through nodes that are using any one of these 3, soon 4 implementations, and you won't even see it. It's interoperability at every level of the protocol.
Is there any integration test suite which can enforce this, check this?
Yes, there is. It's a work in progress, but Christian Decker has a testing framework in Python. It's a relatively new thing, but it will grow, and we will add test vectors for us and people who also want to join and build their own implementation. We have some test vectors right now. Yeah, we have test vectors for encryption, for Bitcoin transactions, for the payment request address systems we have, and we'll have more. So it is beginning, but yes, we do have something.
Big theme in this whole community is type safety and using some type level techniques to avoid bugs in compile time. And probably a question to both speakers, like, are you trying to leverage that kind of techniques, those techniques to kind of avoid having bugs, because it seems like then whether you're dealing with what you are.
Yes, we do use the type system. We don't do things that are too advanced because we focus on. We really don't want to have two different branches for servers and Android. That's our biggest worry right now. We're a small team. We already have two different branches. We already have problems because things that work on servers don't work on phones, and sometimes you don't see it right away. And so we haven't used very advanced tools that are not compatible with Android yet. But yes, we do rely on the type system.
Any questions?
I might have missed about the Lightning protocol, but what's the incentive for Bob to pass the transaction to everyone else?
Because you can get paid to relay payments. Basically, if you relay payment, you take a small fee. It will be very small, like 0.1%. But nodes can get paid to relay payments. That's the incentive.
Same as Bitcoin, basically.
Yes, but it's a linear incentive. It's not either you find something or you've wasted everything you've done. Every time you relay payment, you get a really tiny amounts of money, but it's every time.
You mentioned with onion writing that I think the sender chooses the pathway.
Yes.
How is that done? Is that like via some configuration and channel setup, or is it?
Basically, it's because to start with, we'll have a broadcast system for channel announcements. Every time you create a channel, it will be announced to everyone, and so everyone will have a complete map of the network. That's how you choose. So we know it will be a limitation. It won't scale beyond maybe 50,000 nodes or 100,000 nodes, but it's fairly simple to implement, and it gives you an easy way to compute routes. And there are things you can do, like you don't have to announce leave nodes, because if you can't relay payments, it is pointless to add your channel to the routing map. So when I create a payment request, I could include in a payment request a list of nodes that you can use to reach me, and this will reduce the constraints on the routing system. But it's one of the areas where we know we'll have to find something better to scale, but it's first we have to bootstrap the system, and if we can get something that works fairly well with dozens of thousands of nodes, we'll be happy.
So do you imagine that at some point we'll have like web browser extensions you install and have some sort of pre-filled, kind of like almost like app logging or something, where pre-filled like whitelists or blacklists?
Yeah, it's a potential use case. Yes, we are not directly working on it right now, but yes, it is a use case for Lightning. Okay. Thank you very much.